Here we are going to discuss about modes of decay. In our previous videos we discussed what is the reason behind disintegration. So we came to a conclusion that an unstable nuclei will undergo some kind of disintegration or some modes of decay to give a stable nucleus. So there are two basic modes in which this unstable nuclei of a radioactive element may decay and form a stable nucleus. So those methods are alpha emission and beta emission. So here first we are going to discuss about alpha emission. So we know alpha particle is almost that is equal to a helium nucleus. So this is the way in which we will be representing helium nucleus. So when a radioactive nuclide decays by emitting an alpha particle or helium nucleus, there occurs a decrease of 2 units in the atomic number and there will be a decrease of 4 units in the mass number. That is, the new nucleid or the daughter nucleid produced has an atomic number 2 units less and mass number 4 units less than the parent atom. That is, I'll write an example here. Consider the example of uranium 92 to 38. So when this is undergoing an alpha emission, there will be a product plus an alpha particle. Alpha particle will be there. So the product will be, or the daughter nuclide will be having atomic number 2 units less and mass number 4 units less. So here 2 units less means here it will be 90 and here 4 units means 234. So the atom or the product will be thorium. Another example, polonium we are considering. So 84 and 215. So when this is undergoing an alpha emission, so as I told, here atomic number should be 2 units less, so it will be 82, and mass number should be 4 units less, so it will be 211. So you'll be getting plumbum plus an alpha particle, or you can write helium nuclide. This is all about alpha emission. So the parent atom will be giving a daughter atom which have 2 units less in the atomic number and 4 units less in the mass number. So this is all about alpha emission. Now we are going to consider about beta emission. So in the case of beta emission, when a radioactive nuclide decays by emitting a beta particle or an electron, so you will be writing it as, this is the representation of an electron. So there occurs an increase in 1 unit in the atomic number and there will be no change in the mass number because it doesn't have any mass. That is, the new nucleid or the daughter nucleid produced will be having 1 unit plus or 1 unit greater than the parent atom, but there will be no change in the mass or mass number will be same. So here I'll write some examples. Let's consider the example of thorium 90 to 34. So when this is undergoing a beta emission, what according to the definition it says, there will be an increase in proton number because here we are removing an electron. So positive charge will be increased by 1 unit. So here it will be 91 and protactinium will be there 234 there because there is no change in the mass number because we are removing an electron. Beta emission means removal of an electron. It's just like that. Plus you will be getting that electron here. So consider another example of plumbum 82 to 11. So here the product will be bismuth 83. 82 will become 83 and here it will be 234 itself, 211 itself because here it is 211. So it should be 211 here. Plus you will be getting an electron which is getting emitted from the parent nuclei. So what you can see is there will be an increase in nuclear charge and the emission of an electron from the nucleus are believed to take place on account of the conversion of neutron into a proton and an electron during the process. So that means here a neutron is getting converted into a proton plus an electron. So when beta emission is taking place, this electron is going out. So only what is left over here is a proton. So proton means positive charge. So that's why there is an increase in atomic number 1. I repeat, when there is a conversion or when there is a beta emission, what is happening is neutron is getting converted to proton plus electron. So, and that electron is getting removed from the parent. So what is left there? That is a proton. So proton means a positive charge. So that positive charge you can see in the product. The proton is retained in the new nucleus, whereas electron is getting emitted as beta particle or this same beta particle itself. So then the emission of gamma rays takes place at the secondary as a secondary effect of beta emission. In either case, the nucleus formed will be in the higher energy state, and so when it is in the higher energy state, it will always try to come to the lower energy state, and that excess energy is then emitted in the form of gamma rays. So you can't see any change in the parent atom. So that is basically, so gamma decay is considered to be a gamma emission. Gamma emission is considered to be just a removal of some energy. That's a secondary effect, or the excess energy which is contained in the element is getting out of that parent element. So you can't see basically this gamma emission. So this is all about our different modes of radioactive decay. And for your knowledge, I'd like to add upon few things, like based on the observations, like when they started to study about this radioactive disintegration, based on what all observation they have made till at that point when they were discussing about uranium, thorium, radium and all, like all those, how these are disintegrating. When they studied all these things, Rutherford, Soddy, and these two scientists together proposed a theory. That theory is known as the theory of radioactive disintegration in 1902. And according to this theory, this concept is developed. Like an alpha particle disintegration will be like this, or an beta particle disintegration will be like this, and gamma particle or gamma emission will be like a secondary decay. There will be only change in the removal of energy. So all these concepts are based on the theory of radioactive disintegration proposed by Soddy and Rutherford. And here is a question which is related to the topics what we have discussed so far. The question is, how many alpha and beta particles are emitted in the conversion of neptunium to bismuth? So, how to solve this problem? So, here what they have asked is how many alpha and beta particles will be there are emitted in the conversion of neptunium to bismuth, 23793. Here 20983. So first of all, to know what all particles are getting emitted, we should know what is the decrease in mass number. So here decrease in mass number can be given by 237 minus 209. Here it will be 28. Then now from this we have to find how many alpha particles are getting emitted. So we know mass of an alpha particle is 4. So to know how many alpha particles are getting emitted, we should just divide this 28 by 4. So we'll come to a conclusion that 7 alpha particles are getting emitted. Then what we have to find is the decrease in atomic number which should be following this emission of 7 alpha particles. So emission of 7 alpha particle means there should be 7 into 2, because 1 alpha particle means 2 protons. So there should be 14 decrease in the number of 14. So 7 into 2, that is 14. That is the decrease in atomic number that should follow the emission of these 7 alpha particles, because 1 alpha particle means 2 and 4. So 7 alpha particle means 7 into 2. So that is 14. So net decrease in the atomic number observed during the whole change in this reaction, it will be 93 minus 83. So that is only 10. So we should know that the rest, here it is 14 and here it is 10. So 14 minus 10, this will be the number of beta particles. So that is 4 beta particles getting emitted. So the answer will be, so the question is, how many alpha and beta particles are getting emitted in the conversion of this neptunium to bismuth? So we came to a conclusion that this much, 7 is the number of alpha particles which are getting emitted, and 4 is the number of beta particles which are getting emitted. So answer is, alpha particle is 7 and beta particle is 4. Thank you.